All right, so before we begin, I want to do a little review. Raise your hand, don't just blurt it out. Does anybody know what 0 times 0 is? Anyone? Yes. 0, good. All right, so now keep this in mind because everything that we're going to do today is based on the fact that when I take 0 times 0, it equals 0. So now in example number 1, I've got this. I've got x minus 2 times x minus 3 is equal to 0. All right, so now when we find the solution of a quadratic equation, if I multiply this out, that'll give me a quadratic, right? You guys realize that, right?
Yes.
Yes.
All right, so now let's see what that looks like graphically. So if I pull up my calculator here, all right, and I'm going to go into y equals, oh man, I got a bunch of stuff in there. I can enter it in exactly the way that I have it. I could say x minus 2 in parentheses times x minus 3, close the parentheses, and then graph it. Whoops. Let's do a standard fit, right? So we'll do zoom standard, and there it is. All right. Now, if I zoom in a little more, I'm going to set the window. Let's do 0 for my x min, 5 for my x max, and then for my y min, let's do like negative 5. And my y max 5. And look at there. You see what I see?
Yeah.
So what I already know, and I'm going to show you guys today, is that the solution, when we try to find the solution to a quadratic equation, what we're really trying to find is where it crosses the x-axis. All right.
Mm-hmm.
So now let's see what that looks like here. This was important. So I'm going to leave that on the board, and I want you guys to think about this. Don't blurt it out. I want you to think out loud. How do we use 0 times 0 equals 0 to find the solutions or the values of x that we can plug into this thing that makes this whole thing equal 0? Yes.
No.
Yes.
Well, if you take x minus 2 and x minus 3 and say what value of x would equal 0 for x minus 2 and x minus 3, and then multiply together.
Yeah. So basically what we're going to do is we're going to have to say that 0 times 0 equals 0, or x minus 2 equals 0, and x minus 3 equals 0.
X could be 2.
Yeah. Well, hold on. Don't get ahead of me. We started with the simple one, right? We're going to ramp up to it. But yeah, if we solve these out algebraically, if I add 2 to both sides, I get x equals 2. And over here, if I add 3 to both sides, I get x equals 3. Now, what that means is that when x equals 2 and I plug that into this equation, the first factor will equal 0. 0 times anything is 0. If I plug in 3, the second factor, or x minus 3, will equal 0. And so the whole thing will equal 0. Now, if I go and I pull up my graph, check this out. If I hit trace and I plug in positive 2, guess what my y value is?
0.
0. What do you think happens when I plug in 3?
0.
Yeah, let's try it. See, 3.
Well,
Does that make sense? Yes.
it's broken.
Okay.
It's like every time we graph it, it says quit.
Oh, you've got your plots on. Let's turn all your plots off. Now it'll work. Okay. All right. So does that make sense? All right. So now that we understand that relationship, technically this is not example number 1. Okay. Technically, this is just kind of getting our wrapping our minds around the relationship between finding the 0, which we also call the solution. Sometimes we'll call it the root. So when we solve quadratics, we call them solutions, we call them zeros, and sometimes we call them roots. And it depends on the method. But a quadratic, because it has x raised to the second power, we can take the square root or use completing the square, or basically we take the square root at some point in time. So the solution is considered to be a root. We set it equal to 0, so it's considered to be a 0, but it's also a solution. But the solution is, these are the solutions when y equals 0. Okay, so now let's do example number 1. So to actually do example number 1, we're given the following equation. X squared minus 5x plus 6. Now you're going to say, well, Mr. Adams, I think if you factor that, that's what we just did. Yeah, I know, I did that on purpose. If I were asked to find the solutions for this, I want to get to a point where I can use this 0 equals 0. And so what we want to do is we want to factor this. And so to factor this using Mr. Adams' method, and we've done this a couple times already, I would take the first term and the last term and I would plug it in there. I'll do the first one. X times x equals x squared. Right? So now I got to think of two numbers that when I multiply them together, I get positive 6. But when I add them up, I get negative 5, right? We know from experience that this negative 5x has to be the sum of those two terms. So we would say negative 2 and negative 3. That gives me negative 3x when I multiply it out, negative 2x. So this factors into x minus 3, x minus 2 equals 0. Then we set these equal, we already did this, and that's our solution. So now if I go back and I graph the equation x squared minus 5x plus 6, I multiply that out and graph it, it's the same line. Does that make sense?
Yes.
Okay.